This is Jack Jackson. Recall that we have in the unit circle, when we take an angle and put it in standard position and we look at a point on its terminal side which goes through the unit circle, the x-coordinate is the cosine of that angle and the y-coordinate is the sine of that angle. We can visualize that here by the red length is the absolute value of x and the blue length here is the absolute value of sine. And we're able to use those things to help us go from a unit circle representation of these functions to a Cartesian graph version. But we also have some other visualizations here where we can visualize the other trig functions. So in particular, if we're looking at this particular triangle right here from the point here down to the origin, down to this point out here where it meets the x-axis, where this line here is a line that's tangent to the circle at the point there on the terminal side. Notice that makes a right angle there at the point of tangency. Well, if you look at this reference angle here, then the opposite over adjacent of this would be green side over that's radius side, but the radius is 1. So that's the same as the green length is the opposite over adjacent, which is tangent. So that green length is the tangent of that angle, of that reference angle. And of course, when you rotate this around, it will always be the absolute value of the tangent will be that green length. Of course, you just have to know that it's positive in this first quadrant, negative in the second, positive in the third, and negative in the fourth quadrant. Now also we have this brown distance right here, which is actually the secant of the angle. How can we see that? Well, that's in this triangle that we're looking at, it is the hypotenuse, and we do hypotenuse over adjacent compared to this angle here, the reference angle. That's going to be secant of the angle, but the adjacent side is the radius of the circle, which is length 1, so that brown length at the bottom is the secant of the angle. And again, it's going to work out to be positive. You just have to keep track of the sign of it. So that length actually is the absolute value of the secant. And notice, if we look at it, actually the x-coordinate of this point out here, what am I calling this point? G. The x-coordinate point G actually is the secant of this angle, because notice when you're in the first or fourth quadrants, the secant should be positive. When you're over here in the second or third quadrant, then the secant should be negative. Well, that's going to give us a way where we can look at graphing some of these trig functions. So we've already looked earlier about how we could take the unit circle and get the sine, cosine, and tangent graph. Let's see how we can demonstrate the secant graph. So if we look at this additional representations here, again we look at this tangent line, and here I've colored that same distance that we did a while ago. It's in a darker brown here, and so from the origin out to this point on this circle, that's the distance. Well, if I just rotate it around this circle and bring it straight across, that's going to be the y value there. So, in other words, first of all, let's review. Remember that whatever that angle is, wherever we are, that's going to be the same as the x value over here. So it's an angle, which is also the arc length on the unit circle. So that pink length right there is the same length as the pink length over here on the right picture. So on the left, it's the angle theta, which is an arc length in radians, is the same as the x in the Cartesian coordinate system over here. Now what about the y's? Well, if we're on the secant graph, this brown distance here has to be the same as the brown distance here. So it's a horizontal distance on the x-axis over here on the left, but on the right it's a vertical distance here. Now, again, we just have to keep track of the sign. So whenever the angle is in the first quadrant here for terminal side, then that's going up, whereas and it's still going up down here in this quadrant. But when we move into the third quadrant or the second quadrant, that point is below the x-axis. It's a negative secant, so that's below. So here's what we get. So let's look at it again. What happens when we start here? If we start at 0 radians, then we notice that the brown length is 1 there. So we start at 1. Okay, and so as we start at 1, then what do we do when we move from there? So there we're starting at close to 1 there. And as we move around the circle here, look what happens. The point is tracing around here. Well, this brown distance is going to be bigger than 1. In fact, the smallest it can get, the smallest absolute value it can get is 1. And so this circle here that we're bringing around, which has a radius of that length, is bigger than 1. And so we're getting bigger and bigger and bigger as we go around here. Okay? And notice how far out it is now. So way out here is this length. That's the same as the length here. So it's getting quite large. As it gets closer and closer to an angle of pi over 2, it goes way out there to the right, which means that the point on the graph is way up high. Well, what happens when you actually get it at pi over 2? Then actually that tangent line is actually parallel to the axis. I'm almost there. And so there's the function's undefined. So when you finally get to actually pi over 2 for x over here on the right, or pi over 2 for the theta over here on the left, then that tangent line is horizontal, and in fact there is no secant. But then as we come into in here, the brown is way out to the left, so that tangent line's meeting way out to the left. So the graph is actually way down here. So that's a very long distance, but it's way down. Okay, towards negative infinity. But what happens as we come in here? You can see that point tracing up, going closer and closer, back up to still negatives, but way down there. And that's coming in towards negative 1. And finally, when you get to pi, it actually reaches negative 1, and then it turns around and gets bigger, or bigger absolute value, but actually smaller number because it's negative. So further down. So it continues down, going down towards negative infinity. When you get to the third quadrant, we come in from way up high, and it comes down, 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 down towards 1, and then the whole process starts over again. So let's see how that traces out if we see the graph. Here's what the graph looks like. And again, you can see that point tracing out as it goes up and down here. So notice the secant's going to be in a bunch of connected pieces, but those pieces are disconnected by vertical asymptotes. And the vertical asymptotes are at odd multiples of pi over 2. So at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, we have vertical asymptotes. So the domain is all reals except for those guys. Now, let me also demonstrate that with its reciprocal, which is cosine. And let's kind of compare those just a bit. So notice as we start here, anytime you're doing a reciprocal, we're taking this blue length here for cosine and the brown length there for secant. Well, if you take a reciprocal of a number less than 1, positive number, you get a number that's bigger than 1. And when do the reciprocals the same? Well, when the number is either 1 or negative 1. So every time you get y equals 1 or negative 1 here on the cosine graph, it will be the exact same point on the secant graph. And so they touch each other at... So what's a maximum of the cosine graph is a minimum of the secant graph, and vice versa. What's a minimum down here, say at pi, for example, what's a minimum on the cosine graph is a maximum, local maximum, on the secant graph. And again, as cosine goes from 1 down towards 0, the secant goes from 1 up towards infinity. When the cosine hits 0, the secant is undefined, and you get a vertical asymptote. Then as we come down here, the cosine works its way in negatives from 0 working down towards negative 1, and so the secant is working its way up from negative infinity up to 0, to negative 1, excuse me. And then from negative 1 down towards negative infinity as cosine works its way up from negative 1 to 0. Again, when cosine hits 0, secant is undefined. When you get in the third quadrant here, as you're working your way around here, you're starting up way high, so it comes down from infinity down to 1, which it hits right here again at 2 pi, and the whole thing repeats again. So you have, once again, we have a periodic function with a period of 2 pi.